Here we have the matrix vector form of a system of differential equations. So we're going to find a minus lambda I. So we've got 3 minus lambda, 2, negative 8, and negative 5 minus lambda. We're going to take the determinant of that. We've got lambda squared, 5 lambda minus 3 lambda, that's plus 2 lambda. Negative 15 minus a minus makes it plus 16, so plus 1 equals 0. So that factors into lambda plus 1 equals 0. So we have an eigenvalue of negative 1, but it's repeated. So let's go ahead and find the eigenvector or vectors for that. So if lambda 1 equal negative 1, we put that in a minus lambda I. 3 minus minus 1, that makes plus, so that's 4 and 2. Negative 8 and negative 5 minus a minus makes a plus 1, so negative 4 and 0, 0. We can see our dependency there. So let's go ahead and put the variables back in. 4v1 equals negative 2v2. I'm going to reduce them both sides by 2, so I've got 2v1 equals negative v2. So our eigenvector is going to be, let's let v2 be negative 2, so that makes that a 2, so v1 would be a 1. So we only got one eigenvector. We know our solution space is two-dimensional, and so I need to get another vector, and this is where you need a generalized eigenvector. So we're going to next find that, and we take our a minus lambda I system here, and we augment it. Instead of with zeros, you augment it with the eigenvector. So I put a 1 and a negative 2. And now you can see the dependency, so you could do 2 times the first row, add it to the next row, and get your row of zeros. So let's go ahead and put our variables back in. And so basically u2 is a free variable. Instead of calling it t, because we're going to have t in our solution, let's call it s. So let's get u1, putting the variables back in. 4u1 plus 2u2 equals 1. So let's solve this for u1. And where we see the u2, we're going to put in an s. So that's going to be 2s plus 1, negative 2s, because I moved it over. And then I got to divide by 4. I kind of squashed that in there, so let me rewrite it. u1 equals, we'll reduce that, so negative 1/2 s plus 1/4. And our u2 is just going to be s. We can express this eigenvector in terms of, let's factor an s out. So we're going to express this eigenvector and factor an s out in front. So that's going to be 1/2 and 1 for the s terms, plus for the constant terms we got 1/4 and no constant term on the other one. So generalized eigenvectors, we'd have infinitely many. You choose different s's and you'd get generalized eigenvectors. So let's pick the easiest one we can get. Let's just let s equal 0. If s equals 0, then that part's gone, and this would be my generalized eigenvector. So now we're ready to build the solution. So our solution to this is going to be c1e to the lambda, which was negative t, multiplied by the eigenvector. And the eigenvector was over here, 1, negative 2. And then our second piece is going to be c2, and we're going to have t e to the negative t times the eigenvector. But then we need that other piece from the generalized eigenvector, and so that's going to be plus e to the t times 1/4 and 0. That is our solution.